What's up, you freaking geniuses? So in this video, I'm going to give you a basic introduction into trig and teach you how to find triangle lengths and angles in right triangles, right? So first of all, let's just make sure we understand what sine, cosine, and tangent are. Okay, so they're basically just ratios, and they help us find different lengths and angles in right triangles. And one little clever way that you may or may not have seen how to remember what each ratio is by the acronym SOHCAHTOA, right? So you want to use sine when you're given the opposite side and the hypotenuse, right? You want to use cosine when you're given the adjacent side and the hypotenuse. And then lastly, you'd want to use tangent if you're given the opposite side and the adjacent side. Okay, now in case that sounded like gibberish, let's just jump into this first example because I think it's going to make a lot more sense when we do it. All right, so here, as you can see, we're looking for a side length. So here we're given that this angle right here is 35 degrees. We know that this side is given as x, and we know that this side over here is given as 20. All right, so the first thing you want to do is just identify all the sides on the triangle. So first of all, the easy one to always find is the hypotenuse, right? It's always the longest side of the right triangle, and it's always opposite of your right angle over here. So we know that this length over here is the hypotenuse. All right, now is this side the opposite side or the adjacent side? Well, as you can see, it's basically on the opposite side of this angle over here, right? It's not connected to this angle at all. It's on the opposite side. So we know that this side over here is the opposite side. Okay, so then that means this last side over here that's not labeled as anything, that's touching the angle right here, must be the adjacent side. Okay, so for this problem, as you can see, the two sides that we're going to be working with are the opposite side and the hypotenuse, right? So which trig ratio would we want to use? Well, we would want to use sine in this case, right? Because sine uses the opposite side and the hypotenuse. All right, so the way that you set up your problem is by saying here, we're using sine, right? So we're going to say sine of the angle that we're given, and you'll often see this symbol right here, that's just theta, is equal to the opposite side over the hypotenuse, right? So the opposite side over the hypotenuse. So that's our equation that we're going to use. Now let's plug in what we know. So we're going to say sine of theta, and again, theta is just the angle that we're given. So here it's 35 degrees, right? So we're going to say sine of 35 is equal to the opposite over the hypotenuse. So what's the opposite side? The opposite side is x. So we're going to plug in an x for the opposite side. And what's the hypotenuse? It's 20. Okay, now here we're just trying to solve for x, right? We're just trying to isolate it. So we need to get rid of this 20 in the denominator. And the way that we can do that is by multiplying both sides by 20, right? We can multiply this side by 20 and this side by 20, right? So then on this side, the 20s on the bottom and top cancel out. So then on this side, we're just going to be left with x. And that's going to be equal to 20 times sine of 35. Okay, now before plugging this into your calculator, you want to make sure that your calculator is in degree mode, all right? So if you hit the mode button on your calculator, just make sure it's in degree and not in radians. Otherwise, it's going to completely throw off your answer, all right? But in any case, 20 times sine of 35 is approximately 11.47. So that's equal to x, all right? So that's the length of this side, the opposite side over here for x. All right, let's jump to the next one. So again, the first thing you want to do is just identify each side. So as you can see, this side right here at the bottom, it's opposite of the right angle. So this must be the hypotenuse, right? This side over here that's not labeled, as you can see, it's nowhere near the angle that we're given here. So it must be the opposite side, right? And also the angle always opens up to the opposite side. Okay, now lastly, this side right here that does in fact touch the angle is the adjacent side. Okay, so here we're given the adjacent side and the hypotenuse. So in this case, we're going to want to use cosine. So here we're going to say again, the cosine of theta is going to be equal to the adjacent side over the hypotenuse. So let's fill in what we know. So the cosine of the angle, which is 41 degrees in this case, is equal to the adjacent over the hypotenuse. So the adjacent is x, the hypotenuse is 11. So we get x over 11. All right. Now again, we just want to solve for x, so we need to get rid of this denominator, the 11, and to do that we can just simply multiply both sides by 11. All right. So then on this side, those cancel out. So then we're just left with x on this side. So we get x is equal to 11 times the cosine of 41. And that's equal to approximately 8.3. Boom, right? So that's the length of the adjacent side right here. All right, now lastly, let's do this one over here. Okay, so again, just identify each side. So as you can see, this long side down here, it's on the opposite side of the right angle, so this must be the hypotenuse, right? Now, we're given this angle, this is 64 degrees, so remember this side on the opposite side must be the opposite side. And this side that's touching the angle must be the adjacent side. Okay, so for this problem, we know the opposite side and the adjacent side. So we're going to want to use tangent, right? Because that one uses the opposite side and the adjacent side. So we're going to say that tangent of theta is equal to the opposite over the adjacent, right? It's equal to the opposite over the adjacent. So again, let's plug in what we know. So we know that the tangent of theta, in this case, is 64 degrees, right? So we're going to plug in a 64 there. And that's equal to the opposite over adjacent. So that's going to be x over 7, right? X over 7. Okay, so again, we're just trying to solve for x. So let's get rid of this 7 in the denominator by multiplying both sides by 7, right? So those cancel out. So we get that x is equal to 7 times the tangent of 64. And that's equal to approximately 14.35. Boom. All right, now this example is going to be just a little bit trickier, right? So again, the first thing we want to do is just identify all our sides, right? So as you can see, this side is the longest side, so this is the hypotenuse, and then this angle is 36 degrees, and the opposite side of this angle over here is the opposite side, right? So we know that this side, where the 10 is the opposite side, all right? So we're given the opposite side and the hypotenuse. So in this case, we would want to use sine, right? So we're going to have the sine of theta is equal to the opposite side over the hypotenuse. So we get that the sine of the angle, which is 36, is equal to the opposite side, which is 10, over the hypotenuse, which is unknown, which is x, right? So as you might notice, we have something a little bit different here, right? The unknown variable is in the denominator this time, and we don't want that. To solve for x, we want it in the numerator. So in order to do that, we can simply multiply both sides by x. Okay, so then on this side, the x on the bottom and the top just cancel out. So then we're just left with 10 on top. So we get 10 is equal to this part over here, which is x times the sine of 36, right? Now, we're trying to solve for x, right? So we need to isolate it. So we need to get rid of this sine of 36. And to do that, we can simply divide by the sine of 36. And what we do to one side of an equation, we have to do to the other, right? So we'll divide by the sine of 36 on this side also. So whenever you have the same thing on the top and the bottom in a fraction, they cancel out, right? So then we're just left with x over here. So we get that x is equal to 10 divided by the sine of 36. And you'll get that x is approximately equal to 17.01. Boom. All right, now let's talk about how we find angles. And this is going to be almost the exact same method. So again, let's start with this problem right here. The first thing we want to do is just identify all our sides. So first of all, we're given this angle. We don't know what the angle is, so it's just labeled as x. But we do know that this long side right here is the hypotenuse, and then this side over here that's opposite of this angle is the opposite side, right? So we have the opposite side and the hypotenuse. So in this case, we would want to use sine, okay? So we're going to set the problem up the exact same way. So we're going to say sine of theta is equal to the opposite side over the hypotenuse, right? So now let's start filling some stuff in. So here, we're going to say that the sine of theta of the angle, which we don't know, so we're just going to plug in an x for theta right now. And we're going to say that's equal to the opposite over the hypotenuse. So we're going to say that's equal to 5 over 14, right? 5 over 14. Okay, so whenever you have a missing angle, what we have to do in this case is flip the position of the angle and of the fraction. So we're going to put the fraction right here where the x is, and we're going to put the x on the outside. So here we're going to say that x is equal to, and then we're going to have this fraction on the inside this time, right? So we'll put 5/14 right here. And here, we're not just going to put sine, we're going to put sine inverse. Okay, and you use sine inverse when you're looking for an angle, all right? So this is also called arcsine. So either sine inverse or arcsine, you're probably going to hear it called one of those two ways, but they mean the same thing. Okay, and again, you use this when you're looking for an angle. So we're going to find the sine inverse, or the arcsine, of 5/14. And again, that's equal to x. Now this is just a button on your calculator. So just like sine is just, you can pull that up just using a button, you can do the same thing with sine inverse. And the way that you'll be able to do that is by pushing the second button and then pushing the sine button. And then that should probably bring you to this next option, sine inverse. Okay, but in any case, we have the inverse sine of 5/14 is equal to x. So if you plug this into your calculator, you'll get that x is approximately equal to 20.92 degrees, all right? Remember, this is the missing angle that we're looking for. Okay, let's just try a few more here. So again, let's just set it up like normal, right? So we just want to identify all of our sides. So this missing side over here that's not labeled, that's the longest side, so we know that's the hypotenuse. The opposite side over here is this 8, so we know this is the opposite side. And then the shortest side right here, that's, again, touching this angle over here, is the adjacent side. All right, so the two sides that we know are the adjacent side and the opposite side. So we're going to want to use tangent, right? So we're going to say the tangent of theta is equal to the opposite side over the adjacent side. So then here we're going to get that the tangent of this unknown angle x is equal to the opposite side, which is 8, and over the adjacent side, which is 5. Okay, so again, we have a missing angle. So we want to switch the position of the x and the fraction that we have out here, right? So we're going to put the x out here and the fraction on the inside, 8/5. And then again here, we're not just going to take the tangent, we're going to take the inverse tangent, right? So tangent raised to the -1, inverse tangent. Or again, this is called arctangent, all right? So we're going to take the arctangent of 8/5, and again, that's equal to x. So if you plug this into your calculator, you'll get that x is approximately equal to 57.99 degrees, all right? Don't forget your little degree symbol. So if you found the video helpful, definitely leave a thumbs up down below. And if you have any other questions or want to see any other examples, just let me know in the comment section below.